No answer. We have finished these things in the last class. Fatma, what's the average value of AC for the full cycle? Amalia, average value for full cycle? It's very wrong. No, Fatma. No, Amalia. That was not average value. Yeah, for full cycle, average value is 0. Okay, what about the RMS value, Shahzada? RMS value of AC current. How you calculate RMS value of AC current, Shahzada? Shahzada, I can't hear you. Just can you repeat it again? What's the average value of AC for the full cycle? No, sorry, not R. I'm asking RMS value. RMS value of AC current. Shahzada. Mariam. Okay, tell me. At least the RMS value. What's the RMS value of AC? Nazira, how much is the RMS value of AC? Ahmad. Yes, Ahmad is correct. Okay, so let me check your attendance. You all are in class. Abdullah,
Yes, sir.
you are in class. Ahmad is in class. Amalia, Amalia is in class. Fatma is in class. Mariam, are you in class?
Yes, sir.
Okay. Why aren't you responding? Nazira? Yes, Nazira is in class also. Shahzada is. Sania, are you there?
Yes, sir.
Okay. So Sania, what is phasor? We did phasor in the last class, right? What are phasors?
Sir, phasors are quantities which varies simultaneously with time.
What do you mean by sinusoidally, Sania?
I don't know.
Noor, what does sinusoidal means?
We're using sine function.
Yes, sinusoidal means having sine or cosine function. If a quantity have sine or cos in their formula, then that is a sinusoidal variation. Like in the last lecture, we did almost all quantities which were sinusoidal. Like we did this thing. We write EMF, E naught sine omega t. There's a sine is in the equation. That means it's a sinusoidal variation. I write I naught cos omega t is a sinusoidal variation. Either you have sine or you have cos. Here also. 10 sine 314 t is a sinusoidal variation. Just wherever you have sinusoidal variation, it's a phasor. So take away from the last lectures, you should know what is the average value for full cycle, which is 0. You should know average value for half cycle, which is 0.637 of E naught. You should know the RMS value, which is 0.707 of I naught or E naught. Then you should know what are phasors. Phasors which have sinusoidal variation. The best example is sine and cos. And last, you should know phase difference. Okay, let me repeat some questions. Mariam, what's the phase difference between these two quantities? See, I can't explain any other circuit if you don't remember these basic terms. Mariam, what's the phase difference between EMF and current? These two equations are given. No answer, huh? Nazira, what's the phase difference between EMF and current here?
Pi by 2.
Pi by 2. Mariam, this is very easy. See there. Here the phase is pi omega t. Here the phase is omega t plus pi by 2. This omega t and omega t plus pi by 2 have a phase difference of pi by 2. The difference, this is omega t and this is omega t plus pi by 2. So the phase difference is pi by 2. Similarly here, like if I give this example, omega t plus pi by 2 and omega t plus pi by 4. When I ask phase difference, we subtract their phases. We are left with pi by 4. That's a phase difference in phases. Okay, so this is what we did in the last class. Today we will start circuits. While solving circuits, our motive is you will be having equation of EMF. Your motive is to write the equation of current. After writing the equation of current, you should know what is the phase difference between equation EMF and current. Then you will calculate power dissipated. Then you will calculate a power factor. So for power, I'm writing few expressions here. Like this. I will use few expressions here. Average power. Average power. In AC, we calculate average power in this way. It's ERMS multiplied by IRMS multiplied by cos phi. This is how we calculate average power in AC. ERMS, IRMS into cos phi, where phi is the phase difference. Phi is the phase difference. This is how we calculate average power. This term here, cos phi. See, this ERMS into IRMS is same as that of DC. In DC, we wrote that power is I square R, or it's I V square by R. We can write it as VI. This cos phi that we are using here, cos phi is known as power factor. We call this as cos phi. These are two new terms that we will be using in AC. One is average power, ERMS, IRMS into cos phi. Power factor, which is cos phi only, where phi is phase difference. Note it down. Note it down.
Yes, sir.
Okay, can you calculate? Okay, just 1 second. Sania, noted? Okay. Mariam, are you still in class?
Yes, sir.
Okay, not no answer this question. But at least try one question. Nah? Okay, Mariam, tell me. What's the phase difference between these two? EMF and current?
Pi by 2.
Pi by 2. And what should be the power factor now? We did power factor just now. The phase difference, phi is phase difference. The phase difference is pi by 2. Then how much is the power factor? Okay, Mariam, what's the formula of power factor? Mariam, what's the formula for power factor? Cos phi, right?
Pi, yeah.
So if phi is pi by 2, then how much is power factor? Cos pi by 2.
Cos
Sir?
Sorry, internet connection is making issues. Yeah, Abdullah, am I audible?
Yes, sir, you are.
So is my
Yes, sir.
voice cracking? It's not cracking, no?
No, sir.
No, sir, not.
Okay. Okay, let's start with the first circuit, the circuit having resistor only. So we have a resistor. This is resistor R. We connect this resistor to an AC supply. This is the symbol of AC supply. The AC supply is E is equal to E naught sine omega t. We connect it to this AC supply. So we need the equation of current. Equation of current here. So for equation of current, see, in all the circuits, our motive would be same. We will be having the equation of EMF. Our target would be to get the equation of current somehow. So the current is EMF for resistor. You can use this Ohm's law that current is EMF by resistance because resistor follow Ohm's law. You can write this as it's E naught sine omega t divided by R. So as you know that voltage by resistance is current. If I divide, I call this as equation. If I divide the peak value of EMF with the resistance, I will be getting peak value of current now. If I divide RMS value of EMF with the resistance, I would be getting the RMS value of current. So this E naught by R is I naught. So when I do these substitutions, I get I is, let's call this as 2. Let's put 2 in 1. Put 2 in, not 2 in 1. Let's name this as equation number 1. This as equation number 2. This as equation number 3. We'll put 3 in. So this is 1, this is 2, this is 3. So when I put 3 in 2, I get I is equal to, see, instead of this E naught by R, I'm writing I naught. I is I naught sine omega t now. So this is the first equation that we need. That is the equation of current. So if the equation of EMF is this, E is E naught sine omega t, then this is the equation of current, that I is I naught sine omega t now. This is the equation of current. If you look at the phases here, phase of this is omega t, phase of this is omega t. So what's the phase difference between them, Shahzada? Just look at equation number 1 and 4 carefully. What's the phase difference between them? Yes, Shahzada. Sorry? Oh. I'm asking about the phase difference between EMF and current, Shahzada. Is there any phase difference between them? No, sir. Both have same phases, no? This is also omega t, this is also omega t. So EMF and current are in same phase. So that's the first result. You have the equation of current and you also have the peak value of current. So from equation 1 and 3, we can conclude from 1 and 4, we conclude that phase difference is here. Phase difference between EMF and current is here. This is the phase difference. Phase difference between EMF and current is here. This we can conclude from equation number 1 and equation number 4. So phi is equal to 0 as a phase difference. Now, if phase difference is 0, then you can calculate power factor. First of all, you need phase difference. Phase difference is 0. Next, you need phasor diagram. This is the phase difference. Fatma, is it clear up to this phase difference? Okay, Sania. Shahzada, is this clear? Why phase difference is 0? See, if you can understand first 3 circuits now, then AC is just the repetition. Yes. Very good, Ahmed. If you can understand first 3 circuits, circuit having resistor only, circuit having capacitor only, and circuit having inductor only, then entire AC is the repetition. That's why I'm giving very stress on each and every topic. Just note it down. Note it down. Then we will calculate other factors, other things. Abdullah, clear?
Yes, sir.
Doubts? Yeah, can I change the slide now?
Yes, sir. So how did we get I is equal to I sine omega t?
This is from this equation. See, current is EMF by resistance, right?
Yes,
So
sir.
instead of this EMF, I write this equation E naught sine omega t. This E naught by R, this term, E naught by R, I call this as I naught. So I substitute instead of E naught by R, I naught. So I get I is I naught sine omega t. Okay,
Yes,
Ahmed?
sir. Yes, sir.
Any other doubt? Noor, Amalia?
No, sir.
Okay, so now, once you have phase difference, we can draw phasor diagram. Noor, how we draw phasor diagram?
So we'll take an arrow which is of length equal to peak value.
Yeah, we'll take an arrow equal the length equal to the peak value. So let's first draw the phasor diagram for EMF. So I'll take an arrow having length equal to E naught and phase equal to omega T naught. So I take an arrow. This is E naught. Inclination here is omega T. So Amalia, this is the phasor diagram for E naught. Now I want to draw the phasor diagram for current. What do you think, Amalia? Where will the phasor for I naught lie? Will it coincide with E naught or not? Amalia. Phasor diagram for current, will it coincide with that of EMF or not? Simple one line question. Will phasor diagram of EMF coincide with that of current? Amalia. It will? Yes.
It will not.
It will not. See, what's the phase difference for current? Omega T. What's the phase difference for EMF? Omega T. So both will have same angle with the horizontal. Their phasor diagram should coincide because they have same phases. See, when I'm taking for EMF, the angle is omega T. So I take angle omega T with respect to x-axis. When I draw it for current, the same angle omega T. So I draw the same thing. So both E and I are coinciding. Is it clear?
Yes, sir.
Yes, sir.
From the vertical, this is I. From the vertical, this is E. So this E and I are instantaneous values. They're simply the instantaneous values. So that's instantaneous value of current. This is instantaneous value of EMF. So from this phasor diagram, you can clearly see that E naught and I naught are in same phase. So this phasor diagram shows that both are in same phase. Phasor diagram shows that they are in same phase. No phase difference between them. So for all circuits, the first equation that I would need is the equation of EMF, which is usually given. Then the next thing that I would need is the equation of current, which is EMF by resistance. Next, I would need the equation of current. From equation of current and EMF, we can get the value of phase difference. Next important term. Once you have phase difference, you will draw the phasor diagram. After drawing phasor diagram, you'll do one more thing. What you will do is you will calculate power factor. Sania, how much is the power factor for resistor? Okay, Sania, tell me what's the formula for power factor? We just have written. Yes, Noor is correct. Mariam, what's the formula for power factor? Mariam, formula for power factor?
Cos.
Cos phi.
Yes.
Sania, how much is phi for this particular circuit? Yes, Sania.
Phase difference.
How much is phi for this particular circuit?
Sir, it is phase difference.
0, 5, 0. So what would be the value of power factor? It would be cos 0.
0.
And
Yes.
cos 0 is 1.
1.
So the power factor of this particular circuit is 1, and this is the maximum value. This is the maximum value of power factor that any circuit can have. That's a power factor. After power factor, you can do few more things like you can calculate average power. What's this? We can also calculate average power. Nazira will tell the formula for average power. Nazira, what would be the formula for average power?
Yes, sir.
Yes, Nazira. What's the formula for average power?
ERMS into IRMS into cos phi.
Very good. And how much is cos phi, bacha here?
1.
No, yes, cos phi is 1. Perfect. Cos phi is 1. So if I substitute these values, you can say the average power for this particular circuit is ERMS into IRMS. And you can say this is the maximum power dissipated. So the question he may ask, someone can ask, when is the power dissipated maximum? This is maximum if EMF and current are in same phase. This is maximum for a circuit having resistor only. This is the average power. After the average power, he can ask you to draw sine curve. It's very simple. Like this is time and this is EMF. So the graph would be this. For EMF, this would be the graph. This is sine curve. Huh? This is for EMF. For current, there are same phase. Like current is also I naught sine omega t. So you can draw the same graph. But the peak value of current and EMF could be different. So I'm taking different peaks. This is the peak value of current. Huh? Okay, in this graph, which one have higher peak value? Shahzada? EMF and out of EMF and current graph, which one have higher peak value? EMF, right? And EMF will have higher peak value than current. So this is the graph, EMF versus simultaneous sine curve, we call it. This is EMF. And that is time. You can put values like here time is 0, here time is t by 2, here time is t. Here time is t by 4. Here it would be 3d by 4. Okay, note it down. Yes, from it. This is the simplest circuit. AC circuit having resistor.
Yes, sir.
Shazada, noted?
Yes, sir.
So you need following quantities for each and every circuit. Okay, let's solve this question. A resistor of 10 ohm is connected to an AC supply and AC supply E is 20 sine 314 T volt. Calculate first part. Peak value of current. Second part. I need phase difference between EMF and current.
Sir, current or EMF? Peak value.
Peak value of current. EMF is given between current and EMF. Third, I need equation of current. Fourth, I need average power, RMS value of current. Fifth part, I need average power dissipated. Average power dissipated. Note it down. Then we'll start the calculations. Good, Emf. Everyone have noted the question?
Yes, sir.
Okay, let's start with this thing now. Okay, Fatma, let's start with you. What is the peak value of EMF here, Fatma? Fatma, just look at
20,
this
20.
equation. 20, very good. Peak value of EMF is 20 volt. Mariam, peak value of EMF is given, resistance is given 10 ohm. Do you remember any relation to calculate peak value of current? See? Can you find any relation to calculate peak value of current? Good, Ahmed. Mariam. No. Nazira, can you find any relation to calculate peak value of current? This is one, no? This is the one. The peak value of current is peak value of EMF divided by the resistance. So this is I naught. This is I naught. Peak value of EMF by peak value of current. Sorry, resistance. Peak value of EMF is 20. Resistance is 10. It's 1 amp. Sorry, 2 amp. That's the peak value of current. Second part. Sania, what's the phase difference between current and EMF in a circuit having resistor only? You just have written. Sania, phase difference. What's the phase difference between current and EMF in the circuit? Sania, just read this statement. Huh? Read this statement and tell me what's the phase difference.
Is 0.
0. Phase difference is 0. The phase difference between current and EMF is 0. Phi is equal to 0. Okay, after phase difference, I need equation of current. So Amalia, do you remember any equation of current for the circuit? Having resistor only? Which equation you will use for current? 1, 2, 3, 4?
Equation number 4.
Equation number 4. Good. So this is equation number 4. This is equation of current. This is equation of current here. So equation of current is this. It's I is I naught sine omega t. Shadada, how much is I naught? Shadada, how much is I naught? How much? 2. I naught is 2 amperes. So I is 2 sine. See, how much is omega, Fatma? Can you calculate omega from this equation? How much is omega? So you can compare it with the standard equation of EMF. E is E naught sine omega t. Yes, how much is omega, Mariam? Good. Fatma, how much is omega? Not 2 pi r. Fatma, just compare. Instead of omega,
314.
what term are you? 314. Omega is 314. So that is the equation of current. I is 2 sine 314. After equation of current, you need RMS value of current. Mariam, at least tell the relation between maximum value and RMS value. Mariam. Nazira, relation between RMS value and peak value of current. See, this is the relation.
Yes, sir.
What's the relation between RMS value and peak value of current?
0.707 into peak value.
Very good. It's 0.707 into peak value. So the RMS value of current is 0.707. And in this question, how much is the peak value? Peak value is 2 ampere into 2 ampere. Fifth part. Last, we need average power dissipated. Yes, Abdullah, what's the relation for average power dissipated?
Sir, ERMS into IRMS.
For resistor, we have this relation. See, for resistor, average power dissipated is ERMS into IRMS. So I know that IRMS is 0.707 into 2 ampere. And I know that E naught is, how much is E naught? E naught is 20 volt. Shazada, how will you calculate ERMS? See, for this, I need ERMS. How much would be ERMS? Shazada, your mic is not working properly. You can type your answer also. How much is ERMS in terms of E naught? Same relation, na? 0.707 into E naught, 20 volt. Now you can substitute both the values here. You can substitute IRMS here and ERMS here. So you can write that your average power dissipated is 0.707 into 20, 0.707 into this much of what is it? A straight formula based. Now we'll do questions on the concept. Noted, everyone?
Yes, sir.
Okay. See the next question. A resistor of 5 ohm is connected to AC supply of 100 volt and 50 hertz. Calculate first part. Peak value of current. Second part. RMS value of current. Third part. Equation of current. Fourth part. Power factor. Fifth part. Average feasibility. Just note this question and tell me what this value is. This 100 volt. This is the average value, RMS value, peak value. Which value is this? Good note. Just note this question and try to solve it. Ahmed, which value is this RMS, average, instantaneous? Which value is this 100 volt? That's my question. No, Ahmed. Okay, just note it down. Just write in chat room. Just first note this question and write in chat room like which value of EMF is this 100 volt? Is this the instantaneous value? Is it the peak value? Is it the average value? Which value is this? Okay, Fatma. No, Fatma, you're wrong. Ahmed, you are wrong. Just write this in chat room. Which value of EMF is this 100? RMS, peak, average, which value is this? Fatma, you're wrong. Ahmed, you are wrong. What about the rest? Yes, Ahmed, now you are correct. Amalia, Sania. Yeah, Shazada, this is EMF. This is EMF, you're correct. I'm asking which value of EMF. EMF may have many values. It can have RMS value, average value. Good, Mariam, you're correct. See, this is the average value. Fine. This is the average value of EMF.
So 100 volt is average.
Sorry, not the average, but the RMS value. See, if in AC, the value is not given, it's not mentioned whether this is average, this is instantaneous, peak, whatever, then take this as the RMS value. In AC, RMS value is the practical value of AC. And usually in home, we get 220 volt AC. 220 volt AC means that 220 volt is the RMS value of AC. If you buy some iron from the market, over the iron it's written this is iron is of 200 volt. Then that 200 volt is the RMS value. So if nothing is mentioned, then this is the RMS value. If nothing is mentioned, then this is the RMS value. So in the first part, you have RMS value of EMF. ERMS you have, which is 100. So Abdullah, if you have ERMS, how would you calculate E naught? The first part, I need peak value of current. For peak value of current, I need peak value of EMF. So Abdullah, if you have RMS value, how would you calculate the peak value of EMF?
Sir, we can find first of all IRMS value.
Okay, then?
Sir, then we can substitute in the equation I is equal, not I is equals to, IRMS is equals to I naught 0.707.
Very good. See, you can do two things. You can either calculate IRMS from here first. What is IRMS? IRMS is simply ERMS divided by the resistance. So ERMS is 100. Resistance is 5. It's 20 ampere. But this is IRMS. I don't need IRMS. I need I naught, peak value of current. So you can use the simple relation. IRMS is I naught by root 2. You can write this as 0.7. 1 by root 2 is 0.707. It's your choice. You want to multiply by root 2 or you want to multiply by 0.707. So you can substitute the values there. IRMS is 20 is equal to I naught divided by root 2. So you can write that I naught is 20 root 2 ampere. That is I naught. This is the peak value of AC current, 20 root 2 ampere. So if nothing is given, that means it's the RMS value. Once you have RMS, you get RMS value of current, then you get RMS peak value of current. Is it clear, everyone? Fatma, Shahzada?
Yes, sir.
Okay. Okay. If now try to solve all parts now. Second, third, fourth, fifth. And write your answer in the chat. I got few answers like I got answers from. Okay, I got answer for the part 1 and 2 only. Solve second, third, fourth, and fifth part. Do it now. Okay, good, Ahmed. I need answers. Right answer of second part. Okay, Noor, good. Ahmed, your answer is wrong. Ahmed, you are wrong. Abdullah, third part is wrong. This 20 is not the RMS peak value, it's the RMS value. Yes, Fatima is correct. Sania, you're wrong. Sania, RMS value is 20. Na? Why are you writing 14? RMS is 20. Yes, Noor, fourth is also correct. Yes, RMS is 20, but in equation, we don't use RMS value. We use peak value. Good, Fatma. Very good. Very good, Nazira. Okay, Abdullah, you wrote root 2 also. Let me check. Okay, yes, you are right. Yes, Abdullah, you're correct. Fatma, power factor is not 0. Just look at the derivation. How much is power factor? Just look at the derivation, Fatma. How much is the power factor? Nazira, I need power factor, not the whole power. I just need power factor. Okay, Abdullah, fourth and fifth are also correct. Noor, fifth is correct. Nazira, I think it's the answer for the part 5. The answer that you're writing is for part 5. Amalia, your answers? Mariam, Shahzada. Sania, you're making mistake in RMS value, peak value. See, listen. Yes, Aman, the average is correct. Nazira, fourth and fifth are correct. See, the value which is given here, this 100 is the RMS value. Sania, just look at the calculations. ERMS is 100. When I divide this ERMS by the resistance, I get IRMS. So it's 100 by 5, which is 20 amp. So IRMS is 20 amp. So if you have IRMS, you can calculate I naught. See, IRMS is I naught by root 2. Put the value of IRMS here, it's 20, it's I naught by root 2. You multiply it here, it's I naught is 20 root 2. I naught is not 20, Sania. I naught is 20 root 2. It's IRMS, which is 20. Sania, is it clear? Yes, Ahmed, both the
Yes.
answers are correct. In the second part, I'm asking about the RMS value. How much is RMS, Sania?
20.
20. So IRMS is 20. Look at the third part of the question. I need equation of current. What's the equation of current here, Mariam? Yes, Mariam. What's the equation of current here?
E naught by R.
No, that's not the equation of current. No, this is the equation of current. See, this one, this one, this is the equation. I naught sine omega t. Okay. Equation means you have equation, you have time in that equation. This is the equation of current, I naught sine omega t. So the third part is asking about the equation of current. That equation of current is I naught sine omega t. Okay, Mariam, tell me, how much is I naught here? Just check the previous calculations. We have calculated I naught. How much is I naught?
20 root 2.
20 root 2. Sania, I naught is not 20, yeah? It's 20 root 2. In equation of
Yes, sir.
current, we use I naught, not IRMS. And Sania, how much is omega? Just compare from here.
314.
See, frequency is 50 hertz, right? If
Yes.
frequency 50
50.
hertz, that means you can calculate omega. Your omega is 2 pi into nu. Your omega is 2 into 3.14 into nu. Nu is 50. So this is 314 radian per second. That's omega. If you have frequency, you can calculate omega. This is also what we did in the last class. We also calculated this in last class. So when I substitute it here, the equation of current comes out to be it's 20 root 2 sine 314t. This is the equation of current. The next part, what I want is the power factor. Nazira, what's the formula for power factor?
Cos phi.
Cos phi. So for resistor, phi is 0. So we get power factor to be 1. Plus 1. Maximum power factor any system can have is of for resistor. Fifth one, average power. The formula for calculating average power is ERMS into IRMS into cos phi. Or for resistor, we know that cos phi is 1, so we're not writing cos phi. Keep on telling me the values. How much is ERMS in this equation? Sania?
100.
100. See, this is ERMS, 100. How much is IRMS here? IRMS is 20.
20.
When you put all these values here, 100 into 20, it's 2000. 2000. Just note it down. We'll do one more question on the same concept. If you can understand one circuit, now then other circuits would be very easy. Explain. Can I scroll it?
Yes, sir.
Yes, sir.
One last question, the same concept. Noted?
Yes, sir.
Yes, sir.
Okay, next. Next question. So an electric kettle of, let's say, 10 ohm is connected to AC supply having amplitude of 100 volt. So you connected this to an AC supply, the amplitude of AC supply is 100 volt. Calculate 100 volt and 50 hertz. Calculate first part. Equation of EMF. Listen, I need equation of EMF, not current. Which value is this 100 volt? Just write in chat room. Is it average value, RMS value, peak value? Just note it, just write in chat room. Good, Noor. Abdullah is correct. Noor is correct. Ahmed is wrong. Mariam is correct. Shazada is correct. Sania is wrong. Amalia. Shazada is correct. Nazira. See, if it is written here like amplitude, amplitude means peak value. I need equation of EMF. Amplitude means peak value. Second, I need amplitude of current. So when I say amplitude, I need peak value of current. Huh? Amplitude of current. Very good, Nazira. Then I need RMS value of current. Next, I need equation of current. Next, I need power dissipated. Average power dissipated. Okay, just note it down. Solve it. So this 100 volt is the peak value. Amplitude means peak value. Note it down and write your answers in chat. I'm giving similar type of questions again and again. I just want you to get used to of these notations, used to of these equations. So Sania. Sania, which value is this? This is peak value, no? First of all, Sania, write the equation of EMF, not the current. First of all, write the equation of EMF. This equation, Sania, this equation number 1, I'm asking. This one. This equation. This is the equation of EMF. Huh? This is the equation of EMF. Write this equation first. Very good, Sania. Good, Ahmed. First part is correct. Good, Noor. First is correct. Abdullah, Amalia. Second is also correct, Noor. Shazada. First part, write the equation of EMF. Huh? Just have to write this equation. This first equation. Just this is the equation of EMF. Abdullah, first is correct, second is correct, third is correct, fourth is also correct, and fifth is also correct. Good. Yes, Noor, fourth is correct. Nazira, second is. Nazira, you need current. See, this is EMF, 100 volt, and you have resistance. Nazira, second is wrong. Sania. Sania, this is the RMS value of EMF. I'm asking you to write the equation. Did you write the equation? Sania, which part is this? The answer that you are writing is first, second, third, fourth. Which part is this? No, no. Sania, see, this is the equation. See, Sania, this is the equation. This equation number 4. This is the equation of current. So find the value of I naught, find the value of omega, and substitute it here. That would be the equation. Yes, Nazira, equation of current is right. Ahmed, yes, peak value is correct. Right. See, amplitude is given. That means E naught is given. E naught is 100 volt. It's given. Frequency is given, which is 50 hertz. If you have frequency, you can get angular frequency, which is 2 pi nu, which is 2 into 3.14 into frequency, which is 314 radian per second. Let's solve first part. Equation of EMF. This is the equation of EMF. E is E naught sine omega t. This is the equation of EMF. E naught sine omega t. Just substitute the values. See how much is E naught? E naught is 100. Sine omega is 314 and it's t. This is the equation of EMF. 100 sine 348. Yes, Mariam, that's correct. Second, you need amplitude of current. So amplitude of current is amplitude of EMF divided by resistance. The amplitude of EMF is 100. Resistance is given as 10 ohm. Resistance is also given. Resistance is 10 ohm. So 100 by 10, which is 10 ampere. Third one. After current, you have RMS value of current. See, RMS value of current is peak value of current divided by root 2. So it's 10 divided by √2 ampere is the RMS value of current. Fourth part, equation of current. This is the equation of current. I is I naught sine omega t naught. I naught, how much is I naught? It's 10 sine. How much is omega? Omega is 314 into t. That's the equation of current. When you change circuit, then this equation will change. For different circuits, you will have different equations. Average power dissipated. P average is ERMS into IRMS into cos. So this is PRMS into IRMS. ERMS is not given. E naught is given. Fatma, how will you calculate ERMS from E naught?
Into 0.707.
So you can write this as either as E naught by √2, or you can write this as 0.707 of E naught. So your ERMS will be, how much is E naught? E naught is 100. So 0.707 into 100. That's 70.7 volt. Next, see how much is IRMS. IRMS is 10 by √2. Or you can say that this is 0.707 into 10. That comes out to be 7.07 ampere. So IRMS is 7.07 ampere. So when you substitute these values, you will get P average is ERMS, which is 70.7 into IRMS, which is 7.07 watt. This is the average power dissipated. This is how we calculate average power dissipated. Okay, just note it down. Now I hope after these 3 questions, these basic concepts are clear. We'll start other circuits, like circuits having capacitors, circuit having inductors. Yes, can I scroll it?
Yes, sir.
Written, everyone?
Yes, sir.
Sure. So that was about the first circuit, the most simple circuit having resistor only. You have various circuits next, but the construction is same. The next circuit is circuit having inductor only. AC circuit having inductor only. AC circuit having inductor only. So if you have an inductor, this is an inductor. Abdullah, do you remember on what principle this inductor works?
So on the principle of Faraday's law of
Very good. Works on the principle of Faraday's law of electromagnetic induction. Means if a changing current passes through an inductor, then it induces an EMF which oppose this changing EMF. So if you have an AC, AC is E naught sine omega t, it's a variable EMF. So this AC will oppose its cause. So what happens here, when you connect an AC to an inductor, the flux through the inductor change, some EMF is induced into it which oppose this applied voltage. So this is equation number 1. The equation is given. Just like that of resistor, from this equation, I need the equation of current. But see, no, the process is not straightforward. For resistor, you can calculate current by dividing EMF with resistance. But for inductor, this equation is not valid. It's not a relation between current and EMF for an inductor. For an inductor, the equation for current and EMF is this. E is L di over dt. This is what we wrote for inductors few days back. So if you can remember self-induction, we wrote this thing now when we were doing self-induction. See, we wrote this thing. So that's the relation between EMF and current for an inductor. You can't calculate current just by dividing EMF by resistance. For inductor, you need this equation to calculate the equation of current. So for equation of current, you will use this equation. E is L di over dt. You can write your di as it's E dt over L. Let's call this as equation number 2. This is equation number 2. Next, what we can do is we can simply substitute 2 in 1 in 2. Instead of this E, I can substitute this thing. Ahmed, why I'm doing this calculation? What's the motive of this calculation? Yes, Ahmed. Why I'm doing this calculation? What's the motive of this calculation?
To find current.
Yeah, to find current. We are doing all this to find the equation of current. So when I substitute E as E naught sine omega t into dt divided by L is equal to di. So you can write that your current is it's E naught sine omega t by L into dt. To get the equation of current, you need to integrate it. So it's E naught by L sine omega t dt. This is an indefinite integral. We don't put limits here because we are trying to calculate the equation, not the value. So we can take this E naught by L outside. We can take this E naught by L outside. And we are left with integral of sine omega t dt. When you integrate sine omega t, the integral is minus of cos omega t divided by omega plus c. This is indefinite integrals. In indefinite integral, we don't have limit. We put a constant c here. So the equation of current that we will get is minus of E naught by omega L cos omega t now. Next, what we can do is you can put this value of this omega L something. Let's first convert this cos omega t. Okay, we'll do it later. But first of all, let's write this omega L. We call this omega L as XL. And we call it as inductive reactance.
Sir,
Yes.
sir, C is that integration constant?
Yeah, C is that integration constant. We'll calculate it. Now this is a new term. XL is omega into L inductive reactance. Here, inductive reactance is playing the role of resistance. See, in this equation, your current was EMF divided by resistance. For circuit having inductor, instead of resistance, we use this inductive reactance. So you can say that this is analog of resistor, resistance. Its SI unit is ohm. SI unit is ohm. So let's call this as equation number, this was equation number 2. I call this as equation number 3. Let's call this as equation number 4. Instead of omega L, I can substitute XL. If I substitute 4 in 3, I get I is minus of E naught over XL cos omega T plus C. Let's call this as equation number 5. Here this E naught by XL, what was E naught by R, Sania? What was EMF by resistance? Sania, we did 3 numericals on the same concept. What was EMF by resistance? Shazada, what was EMF by resistance E naught by R? Yeah, that was I naught. So instead of R, I'm writing XL. So E naught by XL will be your I naught now. So for this particular circuit, for calculating current, instead of R, you will be using XL. You will not use R, you will use XL. Let's call this as equation number 6 now. So let's substitute 6 and 5. Instead of E naught by XL, you can write I naught. So substitute 6 and 5. When you substitute 6 and 5, we get I is, instead of this E naught by XL, this E naught by XL, I'm writing I naught. This XL is doing the work of resistance. This is, you can say that this is sort of resistance for a circuit having inductor. So when you substitute these values here, instead of E naught by XL, when you substitute I naught, you get minus of I naught cos omega T plus. You can fix this C to 0. This C comes out to be 0. So if you want to prove how this, although that's not part of syllabus, but if you want to prove how this C comes out to be 0, take average value for the full cycle on both the sides. Both the sides. So the average value of AC for the full cycle would be 0. This will be 0. This will be 0. So your C will comes out to be 0. C comes out to be 0. When you put C equal to 0 here, you will get I is minus of I naught cos omega T. That is equation number 8 now. There is one small issue, that is of cos omega T. In trigonometry, you can convert cos into sine. You can write cos omega T as sine pi by 2 minus omega T. Those who don't have mathematics, you have to memorize this thing. This is the relation between cos and sine. You can convert cos into sine using this equation, sine of pi by 2 minus omega T. Let's call this as equation number 9. When we substitute 9 in 8, we get I is minus of I naught. Instead of this cos, I'm writing sine pi by 2 minus omega T. Next, what you can do is you can multiply this negative sign inside and you will get I is I naught sine minus pi by 2 plus omega T. Yes, no, this is the same equation. Cos is sine 90 minus theta, right? So you can take this negative inside, so it will become negative, it will become positive. So you can write this as I naught sine omega T minus pi by 2. Let's call this as equation number 10. So this is the equation of current. That's why I was saying that equation, the circuit having resistor is very easy, straightforward. From equation to current, you come in 3 steps only. No? Just have to divide EMF by resistance. But for all other circuits, the lengthy calculations. So from this equation of EMF to this equation of current, these are the steps. And see, the formula that one should memorize are this: XL, the SI unit of XL, the equation formula for peak value of current, and this thing, equation of current. Just note it down. Then we'll see phase difference, power factor, everything. Note it down. This calculation can seems complicated for the one who doesn't have maths. Sania, you don't have maths, no? Or you have?
No, sir.
You don't have maths. Tell me once you have written. Okay, Sania.
Sir, it is inductive reactance.
Yes, inductive reactance. Analog of resistance. For resistors, we have resistance. For inductors, we have inductive reactance. For capacitor, we will have capacitive reactance. Abdullah, Noor, noted?
Yes, sir.
So can you scroll up for a while?
Okay, Ahmed.
Yes, sir.
Okay, so let's discuss something. So if we look at the equation of current and equation of EMF, Amalia, from equation 1 and equation 10, can you conclude whether the EMF or current are in same phase or in different phase? Just look at equation number 1, the equation of EMF, and the equation of current. Amalia, can you conclude whether they are in same phase or in different phase?
Different phase.
Different phases. What's the phase difference between them?
Pi by 2.
Pi by 2. Very good. See, this is the equation of current I naught sine omega t minus pi by 2. And this is the equation of current I naught sine omega t, EMF. For EMF, phase is omega t. For current, phase is omega t minus pi by 2. So both have different phases. So current and EMF are in different phase. Have phase difference. Phase difference of pi by 2. Pi by 2. Ahmed, which one leads and which one lag out of EMF and current?
EMF leads and current lags.
Current lags. Current lags by pi by 2. So you can say
Pi
that
by
current You can see this is omega t minus pi by 2. So current lags EMF by pi by 2. So current lags EMF by a phase difference of pi by 2. So that is the equation of current I naught sine omega t minus pi by 2. Current lags by EMF by a phase difference of pi by 2 now. So this is the phase difference between them, pi by 2. This is phase difference. Okay, next is phasor diagram. You need phasor diagram also. So when we draw phasor diagram, we take an arrow. First, let's start with EMF. See, for EMF, the angle is omega t. The length of the arrow will be equal to E naught. So I take an arrow. The length is equal to E naught, and this angle is omega t. For current, the length of the arrow is I naught, but phase is not omega t, it's omega t minus pi by 2. Omega t minus pi by 2 means this is omega t and this is pi by 2. So from the diagram, you can see like your current lags by EMF by a phase difference of pi by 2. After phasor diagram, I need power factor. Shahzada, how we calculate power factor? Formula for power factor?
Sir, cos phi.
Cos phi. How much is phi in this equation, in this circuit for inductor? Shahzada, how much is phi for
0.
inductor? Not 0, see. How much is phi? How much is phase difference?
Pi by 2.
Pi by 2. So your power factor will comes out to be cos pi by 2, and that is equal to 0. After power factor, you can calculate average power. So Mariam, what's the relation for average power? Mariam. Nazira, what's the relation for average power?
I RMS into ERMS
Then
into 0.
cos pi by 2, yeah, it would be 0. So circuit having inductor only, average power is 0. Average power is 0, that means no heat dissipation. Means there is no wastage of energy. Power dissipated means part of energy dissipated as heat. So that means no heat dissipation. No part of energy dissipate as heat. No loss of energy. There's no heat dissipation here. Okay. After average power, they will ask you to draw sine curve. See, for sine curve, I will use these two equations. One is EMF, which is E naught sine omega t. And for current, I will use this equation. I can either use this equation, I naught sine omega t minus pi by 2, or I can convert it into cos. I can write this as minus of I naught cos omega t. This will be easier to start with. So this equation is here. Huh? This is the equation. I convert this equation into this. But to draw a graph, I'm using E naught sine omega t and minus I naught cos omega t. When you plot the graph, this is time and this is EMF. E is E naught sine omega t. That means your graph would be sinusoidal. This is for EMF. But for cos have a different variation. This is the variation of cos. Let me just draw cos for you. See, this is the graph for cos omega t. But since this is minus sign, so this will get reversed. So it will go like this. So this is the graph for cos and this is for minus of cos. So we'll draw this graph here. So this is for current. If you look at it carefully, this is time t by 2. This is peak value of EMF, E naught. This is peak value of current minus of I naught. When your EMF is maximum, your current is 0. When your EMF, this is T by 2 time. EMF is 0, your current is maximum. Similarly here, this time is T. So this is for current. This is the peak value of current. You can say this is I naught. This is E versus time graph. These graphs are very, very important for your objective questions. You will
So
have
that's
these.
also T by 4, right?
Which one? Yeah, that's
T
T
by
by 4.
4, right?
Yes. You will be given these graphs, and from this graph, you have to pick which circuit is this. Is this for resistor? Is this for capacitor? Is this for inductor? These graphs are extremely important for objective questions. You will. Yes, no, it's a single graph, no? It's one graph. And this is for EMF. One
No,
for
sir.
EMF and another for current.
Sine graph for current.
No. So for current, you don't draw sine graph, you draw cos, because it's not just sine, it's omega t minus pi by 2. So the sine get converted into cos. This is cos graph, but due to this negative sign, it gets inverted.
Okay, sir.
So if you want me to write everything properly, just give me 1 second. Just give me 1 minute. You will get confused. See, this time is t by 4. This time is 3t by 4. So the graph for current will goes like this. This is maximum when your current is hit. Then it touch it 0. Then it goes like this. This is for current. It's a peak value of current I naught. This is for current. Do it. But please revise this thing till Thursday. Because all circuits that we will start on Thursday will be based on these circuits only. If you will forget these circuits, it will be tough for me to explain the new circuits. We still have capacitor, and then we have combination of all these. The combination will use each and every concept. So it's not a part of this graph. That's just it's not a part of the regular discussion. I'm just showing how to draw cos and how to draw minus of cos. This graph for cos theta and this is for minus cos theta. So for every circuit, you should remember all these things: the equation of EMF, the equation of current, the formula for the peak value, the phase difference, which one is leading, which one lags, and these terms like power factor, average power, simultaneous sine curve, and everything. Note it down. Yes, no, this is what happens in AC. That's the meaning of phase difference. When we say there is a phase difference between EMF and current, that phase difference means this thing, that EMF can be maximum when your current is 0, or your current can be maximum when your EMF is 0. That's the meaning of phase difference.
So can you move a bit up?
This one?
Yes. Phasor diagram.
That's the physical meaning of phase difference. In AC, it's possible when your current is maximum, your EMF is 0. Your EMF is maximum, but your current is 0. That's the physical meaning of phase difference.
So the phasor diagram.
Noted?
Yes,
Yes.
sir.
Noted?
Yes, sir.
Now draw the sine curve. The sine curve is extremely important. Just looking at the curve, you should be able to decide what circuit is this. So if this is starting from negative, then this is for inductor. If it is going in this way, like if it is pure sine curve, then this is for resistor. This is for resistor only. Looking at the curve, you should be able to decide which circuit is this. Every circuit have its signature sine curve. Noted? Okay,
Yes,
so
sir.
let's stop here. Thursday we'll continue with this thing.
Okay, sir.
And please